Hello students, welcome to my YouTube channel UPSU Technical Center once again. Last lecture I have discussed how we can remember to draw a step-up chopper. Today I will discuss step-up chopper. Today I will discuss step-up chopper circuit diagram and its operation along with waveform and small derivations. How we can say this is step-up chopper and the level of voltages from where we can step the voltages and how much we can step the voltages. These all topics I will cover in this lecture. Initially, in the last lecture, I have told about the how to draw the step up chopper. Now, here I have drawn to reduce the time three diagrams of a step up chopper. Look at here, it is the voltages Vs. Okay, so here the voltage Vs is the supply voltages as we know. Next, L is the inductor. L is the inductor. D is the diode. In the step down chopper, diode is called as freewheeling diode, but here diode is called only diode. Load is here and CH is chopper. It is also called CH, and the voltage across the load is V naught. V naught is the output voltages, not signifies the output voltages. Okay, so here I will draw two consecutive pictures. One pictures here will consider the chopper is on state, and here in this picture we'll consider chopper in off state. Okay, so as in the previous diagram, this is Vs, this is L, this is diode, this is load. Okay, so this is as before diagram, all are same. Consider the red color to better to understand the switch is in off state. So switch is in off state here. Now switch is in off state. So switch is in on state. So switch is in on state. That means here I will say, here I will discuss when chopper is on. That means I will discuss the T on state. It is much thicker. It will be better if we consider this. So this is T on state. Now for this T on state, look at here, this is the supply voltage and this is connected to the inductor and it is closed by a switch. Chopper here we consider IGBT switches. When it is shorted, there is no way to current passes through this diode and load. Why? Because chopper resistance is negligible, we can consider it is almost zero. All current will pass through this path. Okay, so current will pass through this path. So this will be the flow of path. Okay, so this will be the flow of path of current. So this is the path of current. So here current will flow through this path. Let this current is I naught. Okay, when current will flow, this inductor will be charged with positive and negative. Okay, so current will flow through the inductor. And what will be the voltage across inductor? As we know, there will be no voltages across the IGBT switches or CH chopper. It is called chopper. So there will be no voltage drop. So almost Vs voltage applied across the L also. So here in short we can say the voltage across inductor VL will be Vs. Take it Vs according to symbol Vs. So there will be current flow through this shorted path, chopper path. No question to current flow through the inductor. And here, as per the previous diagram, the voltage that we can consider here, the voltage across this is V naught. So here, as per no current flow through this load, V naught will be 0. So very important discussion is there. It is very important when we will draw the waveform. So as we know, the output voltage is 0 and no question of current flow through this load. So the voltage is 0, no current flow through the load. So what will be the nature of current and voltage? Now consider the state of time. Suppose this is our on state. This is our on state. And this is our off state. Similarly, this is for T on, this is for T off. Okay. Similarly, this is for T on and this is for T off. So in the on state, current will increase. At the on state, the current will increase, but the current will increase to the path. The current will increase, so current will increase to the path. So this way the current will increase. Suppose it will be the direction. Current will increase. Now, next consider when the switch is off. So switch is off. This is as before, this is Vs, this is L, this is diode, this is load, and this terminal as per our conventions, this is our V naught. When switch is stopped, as we know, the inductor will store charge and it will not decay all the charges at a time, at a moment. So it will reduce these charges slowly. So here the nature of charges and decay of charges is slowly. So that's why there will be a chance that will be a chance or that will be the process that it will interchange its polarity. It will interchange its polarity. So this will become minus and this will become. Look at here the polarity is plus and it is minus. So this plus is added with the plus minus. So this voltage source and this voltages. How much voltages is there? This voltages is how much? As we know, these voltages will be LdI by dt. Okay. So here it is LDI by dt and Vs will be applied, and there will be no path. Chopper is open, so it will directly connected to the load via diode. So the voltage across the V0 will be some value. What will be the value, and what will be the value of current, everything I will discuss. Look at here. Here the V0, the voltage. When, write down again, when chopper is off. That means T off. Here I have written in the capital letter, here it is in the small letter, everything is same. So V0, okay, it will be the same symbol. V0 will be equal to how much? V0 will be equal to the summation of supply voltages, as well as there will be some voltages, that is V L di by, and here V L, when the voltage across the inductor is connected in series supply, the value of the V0 will be higher in the T of stage. So there will be some voltages will be available. As the current is flowing through this load, here the load, here the inductor will decay its charges. So therefore the current will decay. Current will decay. So what will be the value? So this is our output supply voltage V. This is our V input, which is equal to Vs. It is our current I0, which is flowing through this load just now. So this will be value from I0 min to I0 max. So current will vary from I0 min to I0 max. Look at here, the current will increasing from I0 min to I0 max when the chopper is on. When the chopper is off, the current will decrease from I0 max to I0 min. And this will repeat and this will continue. And we get some voltages, and this value will be much more than the output, much more than the supply voltage, and this will be the waveform of V0. This will be the value of V0, and V0 will be higher, and here the voltages of V0 will be this. This will be the output voltage waveform. Okay, so there will be a confusion. It would be better to draw above line. So this will be the output. And this voltages is more than the Vs, it is mentioned over here. Now what will be the waveform of current? So waveform of current is what? This is the waveform of current. That will be the value of I0. This will not the I0, this will be the Is, that is the supply current. That will be the supply. Here it will be the supply current. Here supply current and I0 will be same. But here supply current and I0, it is different, you can see. Whatever, what will be the current through the load? The current through the load will be some different. Here will be some drop. So what will be the drop? This will be the drop, and this will be the actual drop. So draw it appropriately to get the result proper. So here is the current waveform, and it is same as before. This is I0 max, and this is I0, and this thing will repeat it in the in the above cycles also, or above time. So we can consider the current will increase, then decrease. Similar way, the this will be the output voltage waveform. So here will be the current waveform. So this way. So here this will be the output current waveform. So in this way, and it will continue. Now I will discuss some derivation. Some derivation I will discuss the value of duty ratio or output voltage. So before the discussions, here we consider when this operation is going on. When this operation is going on, there will be no energy loss. Okay. Another thing we must discuss, the current flow through this path in the off state will be some different. So it will be the flow of path. Okay. So now come to the derivation. So there will be no energy loss, and we will follow the law of conservation of energy. So when the energy is stored to the inductor, we can see energy stored in the inductor. Here inductor means L. That will be treated, or that will be defined in WIN. That will be how much? Half into value of stored energy. We'll take the total current. Total current means what? That will be the value of I0 min plus I0 max. Next, the energy stored, the voltage across the inductor is Vs and required time is T1. So the energy stored is occurred now again when energy release. From the inductor, we can say energy release. So this will be, you can say, W naught. That will be same as before. Half of total current, that means I0 min to I0 max, that is the changes of current. Next, the voltage across the inductor is this much, will be V naught minus Vs, very important thing, V naught minus Vs, and the period is T off. And consider no law, that is Win is equal to W naught. So it is now clear to us both are equal. So total amount of energy charge will be total amount of energy release. Both will be same. There will be no loss. যেটা আসছে যতটা চার্জ হচ্ছে ততটা পরিমাণ চার্জ হচ্ছে ততটা পরিমাণ চার্জ রিলিজ হচ্ছে that means the total amount of energy gathered equal to the total amount of energy released. जितना खाते हैं उतना ही छोड़ते हैं, नो लॉस होता है, कहाँ पे भी कुछ भी एनर्जी गुम नहीं हो रहा है, ठीक है. So this will be the W min, W in and W out. So now consider these two equations, and if we consider this equation, the value is half of I0 min plus I0 max into Vs equal to into T1 equal to half of I0 min plus I0 max into V0 minus Vs into T off. So give a multiplication. So these are equal. So from the theory of energy balance, so both are equal. So you can see this portion, the half into this, that part will be cancelled. So only Vs into T on V naught minus Vs equal into T off are there. So we can Vs T on plus Vs into T off, that means T off, okay, and V naught into T off. Now we know T on and T off. this total period is called T, and T is equal to T on plus T off. It is clear to us. Both are equal. Both the summation is equal to T. So here we can write Vs into T. Total time period equal to V naught into T off. So what we have to do now? We can easily calculate V naught equal to Vs into T by T off. So this is our formula. Sorry. Yes, this is our formula. So this is the important formula, and you must give us 3 star. And this formula you can simplify in such a way: V naught is equal to Vs. Here, look at here, T equal to T on plus T off by T off. So you can say T on by T off plus on off in such a way. So this will be not good. If we consider Vs into T by T off means T minus T on, because we know T off equal to T minus T on, as we know. Now divide this part, this portion, T, numerator and denominator. So T by T, T by T, T on by T, or simplified way Vs into 1 by 1 minus T on by T. Now T on by T is equal to alpha. So we can write V naught is equal to Vs by 1 minus alpha. So this is all about the derivation. Wait for a while, there is some error. So keep it inside the box. This is also very important. You can give 5 star. So here V not equal to Vs minus Vs by 1. So if we consider alpha equal to G, that means there will be no duty cycle. Okay, condition when alpha is equal to G. What will happen? Then V naught is equal to Vs. So no step up. If we consider alpha is greater than 0, that means V0 greater than Vs. That means with the variation of alpha, we can vary the V naught. But here minimum value is Vs. If we increase its value, it will increasing. And if we see the nature of graph of V naught versus duty ratio, this will be the nature of graph V naught, and this will be the value of alpha. What will be the nature of graph? Suppose there will be some value of voltage is Vs. So this is our initial value. So graph will start from here, and the nature is in such. With the variation of time, the graph will increase. That means it will tends to infinity. When it will become infinity? When alpha equal to 1, then V naught equal to infinity. And alpha equal to 1, that means T on equal to T off, because alpha is equal to T on by T. When alpha equal to 1, then T on is equal to T. That is no T off. Not true for not true sorry not true for practical case. Practically not true. So there will be some little bit of T off. So we get some value, and in this last moment of this lecture I will conclude that step up chopper means it will step up the voltages from the supply voltages, and minimum value will be Vs when there will be no duty cycle. That means alpha equal to 0. Otherwise in rest of the part, when alpha is increasing, it will increasing, and it is exponentially rise. But when alpha is equal to 1, then there will be chances of value of infinite. But it is theoretically, practically it is not, and it will not happen. This is today's lecture. This is all about my step up chopper lecture. Here I will discuss the step up chopper structure, step up chopper operations, and its waveform, as well as some little bit of derivations. And very important discussions is that the formula is very important. 3 star, 2 star I have already mentioned, and I also give a trick over here. This will you have to remember. And next class I will discuss some mathematics. Dear student, I am following P.S. Bimra book. This is very user friendly book. You can follow, as well as you can follow my lecture. If this lecture is profitable, valuable, kindly put a like and share to your friends. And those are new, subscribe to my channel. In future you will be benefited. I can assure about this. Thank you very much to all of you students. Thank you. Thank you very much. Okay.